In this lecture, I will show you a few multimeters and walk you through all of its functionalities, and also help you decide the best multimeter for your use case and your budget. The multimeter is an essential tool that you must have with you. As the name implies, they can measure many different parameters like voltage, current, and resistance. The most basic multimeter will at least be able to measure those three, and more advanced one can measure capacitance, temperature, and even sense high voltages. Multimeters can be manual ranging like this one or auto ranging like this one. Multimeters can also be digital like these three or can be analog. Analog multimeters are good for one thing only: visualizing the changes in voltage or current. The needle takes some time to move, and therefore you can visualize small changes which would have been gone unnoticed in the digital multimeters because of their high speed and numerical display. Now, before you measure anything, you should make sure your probes are in the right socket. Let's start with the most basic functions of a multimeter. Firstly, we have the resistance measurement mode. In the auto ranging multimeter, it's pretty simple. Just plug your probes. The black probe goes into the common port, and the red probe goes into the volt, ohm, and milliampere port. Now you can turn your dial to the resistance measurement. Now simply take a resistor that you want to measure. Let's suppose you want to measure this one. You simply place the probes on the resistor. Now make sure you don't hold it in your hands, or sometimes it can affect the reading, because now your body is in parallel with the resistance being measured. For the manual ranging multimeter, you have a few different settings for the resistance measurement. As you can see, if you don't know the value of the resistor, you can start with the highest setting and can switch one step at a time, getting lower and lower until you find the desired accuracy. If you exceed the max rating written here, then you will get an error which will show 1 on the display. So now measuring the same resistance, firstly we will start with the highest possible setting, 2000K. It shows 003. We can step it down a bit. As you can see, the decimal place has shifted. Now we are getting 3.1. Again one step below. Now we are getting 3.08. One step again. Now it's showing 1. So what it means is we have overgone the maximum range of this, which is 2000 ohms. So we'll stay with the 20K setting. So the value according to this multimeter is 3.22 kilo ohm. And according to the auto ranging multimeter, 3.14. It's rising. 3.16. Now to measure voltages, we have two categories, AC and DC. To measure both, the basic principle remains the same. With the auto ranging multimeter, you can simply select voltage, and whenever you have two or more parameters in the same position, like here we have voltage AC and DC both, you can switch between them by this function button. Now for the manual ranging, it is the same principle again. If you don't know the value, then start with the highest setting and gradually decrease it one step at a time. Now let's measure a 9-volt battery using both multimeters. This is a used 9-volt battery. So for the auto ranging, we simply set it to volts and DC. And we can simply probe the battery. As you can see, it's showing negative because we have connected it in the wrong polarity. I have connected the negative probe to the positive. So it doesn't mean anything. We will get the same reading just with a negative sign. So it's showing 0.45. This one is completely used. Now for the manual ranging multimeter, let's start with the 1000 volts setting. Now we can start decreasing it one at a time. Now we are getting 0.44 volts. And now if we get into 2000 millivolt range, we are getting 443 millivolts. Now if we step it down a bit further, then we will get an error. This states that we have exceeded the maximum range of this selection. Now for the current measurement, we have to be a little careful. In order to measure a current through a device, we have to break the circuit and place the multimeter in series with the device. Unlike voltage, where you can simply put the probes in parallel with the circuit. Firstly, you need to start with the biggest value range, since we don't know the current which is flowing in the circuit. Now to measure current, firstly you must place the probe in the right socket. The common remains in the common socket, but if you want to measure a higher value of current, you need to remove this and place it in the 10 ampere socket. Same is the case for this multimeter. The common remains in the same position. This socket is only for volt, amp and milliamperes range, and if you want to measure 10 amps, you need to remove this probe and place it in the 10 amp socket. Now to measure the current, in this case we have a normal 12 volts bulb here. We need to break the circuit and place the multimeter in the series. Without the multimeters, the circuit looks like this. Now we need to break the circuit. Now we set the multimeters to 10 ampere range. Now we connect the multimeter in series with the circuit. As you can see, we get a reading of 2.73 amperes. The reading had a minus sign because the polarity was reversed. If we use the right polarity, we will get the value without a negative sign. Now for the auto ranging multimeter, you again have to switch the probes to the 10 ampere, and now we can set the dial to amperes mode right here. As you can see, this auto ranging multimeter can measure both AC and DC amperes, while the manual ranging one can only measure DC. Now doing the same with the auto ranging multimeter, we break the circuit and place the multimeter in series. Now if you want to measure smaller current values in milliamps, you need to switch the probe back to the volt ohm and milliampere socket. This one. Same for this one too. Always be careful when measuring currents. If you try to measure a higher current in the wrong setting, the multimeter might get short circuited and blow up. Now for smaller currents, we will use this example, just a simple LED. Now for the manual ranging multimeter, you can start with the next maximum setting, which we have 200 milliamperes, 20 milliamperes and 2000 microamperes. So we will start with the 200 milliamperes. Now to break the circuit, we can simply take out any wire, place one of the probes here and the other one in series. And we are getting 2.2 milliamperes. If we step it down a bit, we get 2.13 milliamperes. And if we go to the microamperes range, it is around 1870 microamps. Now doing the same with the auto ranging multimeter. We have a milliampere range here. And as you can see, for the milliamps too, we will use the same port. So this is how you use a multimeter to measure current. Now let's measure the current draw of this microprocessor board ESP8266. This is running a simple program of running an LED for 1 second and turning it off for another second. Now to measure it, we can use a digital multimeter. We will set it to milliamperes range. Now we need to break the circuit and place the multimeter in series. As you can see, the reading fluctuates a bit. The reading gets higher when the LED is on and get back to its normal state when the LED is off. Now to visualize this even better, we can use the analog multimeter. So if we set the analog multimeter to the correct range, which is 0.25 milliamperes, and now connecting it, we can clearly see when the LED is on, the current draw rises. This is why I like these analog multimeters. They are best used to visualize voltages and current fluctuations. Now another useful thing in a multimeter is the continuity tester. With this you can check for any breakages of wire, or you can check if the PCB trace is good or not. To use it, you can set the multimeter to this beeper icon. There is also a diode here. Now whenever we will connect the probes together, you can hear a beep. And it's the same case for this one too. We need to set it to the same icon, but we need to change between these three functions here by using the function button. This one also has a light in it. Now what we can use this setting is to measure if the wire is good or not. For example, if you take this jumper wire here, if you don't know if it is good or not, you can simply place the multimeter in the continuity mode and place the probes on the two ends of the wire. As you can see, this wire is good. Similarly, for this meter too, you can do the same. The manual ranging meter also has a couple of useless features, like the HFE and the square wave generator. The HFE here means the current gain of a transistor, which can be placed here, and the square wave generator makes a 3.3 volt signal with a frequency of 1 kilohertz. Now for the auto ranging meter, this can also measure 4 different parameters: capacitance, frequency, temperature, and pulse width. For the temperature selection, this has an internal thermometer and one external thermometer. When nothing is connected to it, this will show the reading from the internal thermometer, and you can change it in Fahrenheit with this button. Now another useful thing, if you want to measure some external temperature, you can use this probe provided with it. This has a metal junction here, and two plugs. These will go in the common and this plug here, right here. This shows degrees Celsius. So we can plug the probe like this. And now it will show the temperature from the probe. If you hold it, the temperature rises. And this probe can handle very high temperatures. For example, if you use a lighter, the NCV stands for non-contact voltage, and it is a very useful feature if you are working with mains voltages. As the name implies, it can detect high voltages without even probing it. It can measure electrical fields in the air and display the strength with beeping sounds. We also have a light along with the audio warning. To turn it on, we don't need any probes. We can just set it to NCV, and this right here is the antenna. So to use it, you can bring it near any live conductor, like this is a live conductor here. Also using this hertz setting, we can measure frequency of a signal. It also has the option to measure the duty cycle of a signal in percentage. To use it, we can turn it to hertz, and to measure the duty cycle, we can press the function button. This also has a backlight for the screen. You can turn it on by pressing this button, and if you long press this button, it also has a torch. Last but not the least, we have the capacitance measurement setting, which can be used to measure capacitance in farads. To use this, firstly, we can connect the probes. I am connecting a different probes here, which have clips attached to them. Now, before even starting the measurement, you should discharge the capacitor that you want to measure. You can either connect it to a metal, like this. You just need to connect these two leads, so any residual charge get discharged before you start the measurement. Okay, now you can set your dial to the capacitance measurement mode and simply connect the capacitor. Make sure you correct it in the right polarity. Now this will take a few seconds to measure and it will show the reading here. So this is 0.935 microfarad. And in the package it's written 1000 microfarad. So it's reasonably close. Now we can also measure another one. This here is a 3300 microfarad. Larger capacitance will take a longer time to calculate. .285 microfarad. So this one is also reasonably close. Now when you need to buy a multimeter, these two options I showed you are the best to buy. The manual ranging one is under $10 and the auto ranging one is around $20. When you are buying a meter, make sure it has all the functions, if not more, as shown in this lecture, and try to avoid the cheaper options below $10. I will recommend not to go too cheap or too expensive and stay in the $20 to $50 range, and you will find a decent meter. I recommend you get a multimeter which has auto ranging feature like this one. This one is pretty inexpensive and is in the $20 range. In this lecture, I will show you some wire cutters and teach you how to use them. Whenever you want to connect things directly to each other without using a breadboard, you will need some wires. Firstly, you will require to cut the wire to an appropriate length. For that, you can use these cutters. Using them is very simple. Take the length of the wire that you want and cut it by placing it in the jaws like this. Now to expose the copper inside the wire, you will need to remove the insulation from it. For that purpose, this wire stripper is used. To use it, you can place the wire right here, and as you can see, whenever you close the jaws, the hole gets smaller and smaller. So you need to place the wire there and press it just enough so that it grabs the insulation. And now you can pull the wire from the other side and the insulation will be removed. You need to be careful not to apply too much force or the whole wire will be cut. You can also get wire strippers with pre-made holes for different wire gauges. In this, you simply have to select the right size hole and place the wire inside it to cut the insulation. This here is an example. As you can see, the wire gauge is written right here and that corresponds to the hole. So by using the same wire, this right here is 18 gauge. So you need to place it in the hole made for 18 gauge wire. Like this. And now you can press and pull the wire like this. If you have to remove insulation from a large amount of wires, you can get these automatic wire strippers. These work by pinching the wires and pulling the insulation like this. Whenever you press the lever, they grab the wire, these two, and then pull it apart. So for that you need to place the wire here, and when you press the lever, it will grab the wires from both ends and pull the insulation apart like this. This also has a wire cutter inbuilt right here. We also have a variable length selector here, this right here. You can tighten it or loosen it to set it for the different thickness of the wires. Also, we have this length selector here, which you can use if you want to select a specific length of insulation that you want to remove. So you can place your wire on this like this, and it will automatically remove the exact length that you set before. For starters, I suggest you get one of these. These can be used for both cutting the wire and stripping the wire. To cut the wire, you can place it in the tip right here, and it will cut the wire. And for stripping, you can place it in the hole like this. So this can do the job of both a wire cutter and a wire stripper. These are very versatile and are very cheap. You should always have at least one of them. Screwdrivers are an essential tool when working with electronics. You will need them for all sorts of work, like driving screws in a box or adjusting a potentiometer. You can do almost all of your work with a precision set like this. In this one, we have Phillips head and flat head in different sizes here. These are the ones you should buy. Others are optional and can be bought if they are needed. These mobile repairing kits come in handy when dealing with small electronics. They have different bits available, and you can use the included screwdriver to use these bits. Whenever you are working with bigger appliances, you will need these big screwdrivers, like this one. Almost all of the time, only these two sizes will be required, a Phillips head and a flat head. You can also buy a powered screwdriver like this, or an even powerful one like this. These will come with their own bits, so you can take any bit that you want, place it in the screwdriver, and just press the trigger. Now, out of all the screwdrivers I showed you, only a basic set like this right here, is needed for almost all of the work. And it will be a bonus if you have bigger screwdrivers like these. Pliers are another useful tool that you should have. These can be used anywhere when you need to grab something. We have regular sized pliers like this, and we have small needle nose plier like this one. Both of these can be used to bend the leads of a component or hold them in place. Now, if you want your project to be robust and more professional, you will need a crimping tool like this with some crimp connectors. A tool set like this is inexpensive and has a few different kinds of crimps present. From here on, you can see which crimp you require a lot and buy them separately. Now, what is crimping? Crimping is basically joining a conductor and a metal connector by deforming the metal around the conductor. To do so, we take a crimp connector like this. We insert the wire in this hole and we deform the metal by using this crimper. I will demonstrate that now. Firstly, you can take any wire that you want. Like I'll be using this thick wire here. Cut it to an appropriate length that you want. I will be doing 2 connections. Okay, so the question is how much you need to strip the wires. If you see a connector like this one, I will be showing you by connecting these 2 connectors. So as you can see, we will be requiring around a centimeter of insulation removed. Like this. Same for the other wire. Now we take the wire and insert it in the hole until it comes out on the other side like this. We also have a stopper to stop the incoming wire like this. After that, you match the color on the insulation to the correct hole here. Like this here is for insulated ones and this here is for non-insulated ones. So we have a blue insulated connector here. So we will place it in this hole. And now we need to press it tightly. And as you can see, this is connected pretty securely now. Same procedure can be applied for other crimps too. Insert the wire in the hole. Place the crimp connector in the right location, like this, and press it considerably. As you can see, they are connected pretty tightly now. In this lecture, I will show you some miscellaneous tools which don't belong to a specific category but are still useful in making projects. Firstly, we have a precision cutter. This has a very sharp blade and can be used to cut various things like paper. Like this. We also have a box cutters. These come in handy in various projects. Tapes are also useful for fixing things quickly. We have electrical tape. This can be used to cover in connections and insulate them from each other. We also have double-sided tape like this one. As the name suggests, these can stick on both sides. We also have double-sided foam tape, and we also have VHP tape. VHP tape has a very high bonding strength. Now, instead of using electrical tapes, we can also use heat shrinks like this one right here. This is an assorted pack of heat shrinks. You will also require some zip ties like this one. Make sure you have a few different sizes available. If you don't have a bigger zip tie, you can always connect two zip ties together to make a bigger one. You will also require this non-contact voltage tester. This can be used to detect live wires. You can simply touch the pad right here, any of these, and you can connect this other end to a live wire and it will show you if the wire is live or not. Now, to open some enclosures, you will require a spudger like this. You can also get them in these kinds of form. These are plastic spudgers. These will come in handy when you want to open a box which doesn't have any space left. Like this. Now, a scale is useful when you want to measure things, and you must have at least a basic scale present. It will be even better if you get a digital scale like this. To measure something, you can place it in these jaws right here and press it shut. Now, whenever you are making some cutouts on an enclosure or printing something using a 3D printer, you will need to make sure the surface are smooth. To do this, you can use a file like this, or you can even use a sandpaper. To use it, you simply rub the surface with the file. You can also do the same with the sandpaper. In this lecture, I will show you an inexpensive component tester which is good to have in your electronics lab. Whenever you are making a new project or repairing something, you will find the need to test various components to check if they are good or not before using it in the circuit. Testing components before using it in the circuit is a good practice because it will save you a lot of time troubleshooting the circuit. For resistances and continuity, we can simply use the multimeter. But for components like transistors, inductors, capacitors, MOSFETs, and various other components, we require a separate tester. A component tester like this can be bought at a very reasonable price, and it is around $10. I got this as a kit which I soldered and assembled myself. This will be a great through-hole soldering practice if you decide to get it and assemble it yourself. If you want, you can see the full assembly and calibration of this tester on my YouTube channel linked in my profile. Now to use this tester, you have three terminals at the bottom here. Terminal 1, 2 and 3. I have attached alligator clips to make it easier to connect and disconnect components. Using this is very simple. You just need to connect the component you want to test in any orientation and press this start button. Now I will show you some measurements of various transistors, diodes, LEDs, MOSFETs, capacitors and inductors that you see here. Firstly, we have the simplest component, the resistor. So we can connect it on any of the two pins. I am connecting it to pin 1 and 2 here. After connecting it, you just need to press this button. Now it will show you that there is a component connected between pin 1 and 2, which is a resistor, and the value of the resistance is 9951 ohms. Now this will automatically turn off after a few seconds. Now the next most common thing to test is the capacitor. If we take this electrolytic capacitor, this is 16 volt 470 microfarad. So we can simply connect it in either direction. Just before connecting, make sure the capacitor doesn't have any charge in it. I am discharging it by shorting the pins together. Now you can see it shows a capacitor is connected between pin 1 and 2. The voltage loss of the capacitor is 1.9% and it is showing 487 microfarad. And the ESR, which stands for equivalent series resistance, it is 0.37 ohms. Now for the ceramic capacitor, it's 322 picofarads. as you can see. It can also measure huge capacitances like this 1000 microfarad. I also have a 3300 microfarad capacitor. First, let's discharge it. Now, we can also test inductors with it. Just make sure that the insulation is removed from the ends before connecting, because these wires have insulation around them. You can use a regular sandpaper to remove the insulation, or you can burn the insulation using a lighter or any kind of flame. As you can see, it also shows the direction of the winding. This is the pin 1 and this is the pin 2. And it's showing 0.3 ohms and inductance is 0.03 millihenry. Now coming to active components. Firstly, we have a diode. It also shows you the direction in which the diode is connected, the anode and the cathode, the reverse current, which is 12 nanoamperes, the forward voltage, which is 689 millivolts, and the capacitance of the diode. This also works with bigger diodes. These large diodes, which can handle much more current and power. You can also measure LEDs using this. With the LED, you will see the LED turning on and off while the tester is testing it. I will hold the LED towards the camera so that you can see. in the case of LED, we have the forward voltage, the minimum voltage which is required to turn it on. Now we have the transistor. This is a 2222A transistor. Now we will be using all of the three terminals. As you can see, it tells you the type of transistor, NPN, and it shows you the pin out. Pin number 1 is the emitter, pin number 2 is the base, and pin number 3 is the collector. The current gain is shown here, 287, and the forward voltage is 654 millivolts. We have a transistor in another package here, TIP122. I am bending the lead so that we can connect it easily. It shows the type NPN and the pins once again, the current amplification and the forward voltage. Now we can also test some even bigger transistors. This only has two terminals beneath it, and the third terminal is the body of the transistor. You can also test MOSFETs using this. This here is a IRL Z44N. As you can see, it shows it's N-channel MOSFET. 1, 2, 3 is gate, drain and source, the pin out. The capacitance of the junction is 1.57 nanofarad, and the threshold voltage, it's shown 2.4 volts. We can also see the forward voltage. We also have IRF 9540N. This shows P-channel MOSFET. the pinout, the forward voltage, the capacitance of the junction, and the threshold voltage. Now this tester also has some other useful features such as a frequency counter, a frequency generator, a 10-bit pulse width generator with adjustable duty cycle, which you can access by holding the power on button and navigating it by using single clicks. To use the other features, you have to hold the power on button, and now you can cycle them by pressing it. This is the frequency counter, this is the frequency generator, the 10-bit pulse width modulation. This is used for calibration, and you can also turn it off. In all of the previous power supplies or the batteries that we saw, we do not have any form of current limiting capability, which means that if the circuit has a short somewhere, the battery or the power source, they will provide as much current as they can supply. For batteries, these current can go up to many amperes, which can blow up the circuit or melt wires. To solve this issue, whenever we are building a new circuit, we should start with a power supply which is capable of limiting the current to a predetermined safe value. For this use, we have the adjustable power supply, or more commonly known as bench power supplies. A good bench supply will provide you with adjustable voltage with constant voltage function and adjustable current limit with constant current mode. You can find these supplies online for around $100, but I think these are not required for hobby use. A more economical solution will be adjustable power supply module like this one. You can find these online for around $20 and they are certainly worth it. This supply has a buck and a boost converter built into it and can increase or decrease the supply voltage. It accepts input from 6 to 36 volts and can output anything between 0.6 to 36 volts. Up to 5 amperes of current or 80 watts, whichever limit is reached first. You can power this with any source. For example, I will power it using this 12 volts battery, or you can also power it using the AC to DC adapter that we have. Now you can get any specific voltage that you want just by setting the voltage. And with this, you can even specify a maximum current that it will allow. Like right now, it is set to 2 amperes. If we change it to a lower value, like half an ampere, then this will only allow half amperes to flow. Now, whenever the voltage or current reaches the set value, it will go into constant voltage mode or CV and constant current mode or CC. and it will prevent any shorts from happening. Like right now, where we do not have any load attached to it, it is currently in constant voltage mode. And if we short the output, we have a current of half an ampere, which was already set before. Now we can also change the current limit. And it will affect accordingly. Now you can see it is in constant current mode. And if we remove that short, it will go once again to the constant voltage mode. Now this module basically comes with 4 outputs. I have put it in a housing to protect it. As you can see, we have a 4-terminal screw block at the bottom. Here we have voltage input positive and negative, and voltage output negative and positive right here. So these are just wires attached to them. And I have added some zip ties to relieve the strain from the wires. Here I have a LED attached to the output of this adjustable power supply, so that we can see how changing the voltage affects the brightness of this LED. Now before even turning it on, we can set the voltage that we want. I will set it to 5 volts. Now we can start it. Now as you can see, we have 5 volts going out, but there is no current flowing. So it is still in the constant voltage mode. So now what we can do is we can increase the voltage bit by bit. As you can see, the LED has turned on. Now if we increase the voltage, you can see the current rising and this power reading here. And the current is not going above 1 amperes because we have the current limit set. Like at 12 volts, we are reaching the current limit for the LED. So now what we can do is increase the current. We can also use the 12 volts AC to DC converter with this DC to DC adjustable power supply. To do this, we can simply use the input from the power supply like this, and we will be using this bulb as a load. As you can see, this is a 12 volts, 60 and 55 watt bulb. Now if we turn on the AC to DC converter, we will get power. As you can see, we are reaching the current limit set by the power supply, which is 3 amperes, and we have entered the constant current mode. If we increase the current limit, there are many different types of soldering irons available. The most common types are shown here. All soldering irons have the same job of heating the tip to a certain temperature for the solder to melt, but they achieve this in different ways. The two most common distinguishing factors are the power available to heat the tip and the method of regulating the temperature. The first one here has the simplest construction and is the cheapest of the three. It works by directly connecting the heater to 220-volt mains. The heater has low resistance when it's cold and allows large currents to flow. As it heats up, the resistance increases and it reaches an equilibrium state. The power going in is equal to the power lost to the surroundings. These take a long time to heat up and have no adjustable temperature. These are also called fixed temperature irons. The second iron here has some electronic circuit to regulate the power going into the iron, but it has no feedback about the actual temperature of the iron. You can set the power going into the iron by turning this knob, but you don't know the exact temperature you are setting it to. This type is best suited for applications with a tight budget. The third type is a full soldering station. It has adjustable temperature with feedback from the tip of the iron so that it maintains the exact set temperature regardless of the heat loss to the environment. These also have interchangeable tips and they heat up very quickly. Some models also have a hot air gun like this one. This is used to solder SMD parts and also desolder them. This also has a heater like the iron and a blower fan so that it provides hot air out of this nozzle. The temperature of the air and the airflow both can be controlled. Now that you know about soldering irons, it's time to talk about some accessories for it. Firstly, you will require a soldering mat to protect your bench. A silicone mat like this is heat resistant and will not burn even if you place your iron directly on it or if you are using a hot air gun. Also, you will need a few different tips for your soldering iron. These are inexpensive and can be purchased as a set. The most common tip you will require is a chisel tip. It looks like this and you will be using it 90% of the time. The second most common tip is a conical tip like this. This can be used for precision work. The other kinds of tips have very specific application. Now to clean your soldering iron, you have two options. First is a sponge which you can wet with water and use it to wipe your tip like this. Second is a brass wool like this. You can insert your iron into it while it's hot and it will come out clean like this. The main benefit of brass wool is that it doesn't thermally shock your iron and doesn't drop its temperature, while the sponge drops the temperature of the tip when used. I prefer the brass wool because I don't have to wet the sponge every time I sit down for some soldering work. You will also need some kind of flux while soldering. The most common types are a solid flux like this and a liquid flux like this. My personal favorite is this flux pen. It looks and works just like any other pen, but instead of ink, it has liquid flux inside. It is so convenient and easy to use. I highly recommend you get one of these. To use this, you just place the tip on the component you want to spread the flux to, and it's done. Lastly, to desolder, you will require a desoldering wick. This is very fine copper wires braided together. You can place this over the component you want to desolder and place the soldering iron above it, and it will wick away the solder. Also, falling in the same category, you have a desoldering pump. This acts as a vacuum generator. You press it here to charge it and then place the tip over the component you want to desolder, heat the component simultaneously and press the button. This will suck away all the solder.